Good morning, dear students. Last class we discussed about transpose of a matrix. Yes, what is transpose of a matrix? Transpose of a matrix is obtained by interchanging rows and columns. That is, rows becomes the columns and columns becomes the rows. Now, using this property, we are going to explain two new concepts, symmetric matrix and a skew symmetric matrix. Once again, symmetric matrix and a skew symmetric matrix. Symmetric matrix and skew symmetric matrix are applicable only for square matrices. What do you mean by a square matrix? Because we are recollecting everything one by one. What is a square matrix? Yes, one of you. Yes, number of rows is equal to number of columns. Very good. Now, what do you mean by a symmetric matrix? Let A is equal to a matrix, a square matrix Aij. Then this matrix A is said to be a square symmetric matrix if A transpose is equal to A. That is, when you find the transpose, it should be equal to A. Let us take a simple example. Let A is equal to matrix root 3, 2, 2, root 3. It's a 2 by 2 matrix, square matrix. So, what is A transpose is equal to? Rows becomes the columns. Root 3, 2. This row becomes the column. 2, root 3. And when you compare, you can see that A is equal to A transpose. So, that means it is a symmetric matrix. It is a symmetric matrix. Or in general, we can say that for a square matrix to be a symmetric matrix, if Aij is equal to Aji, Aij is equal to Aji for a symmetric matrix. Now we come to the skew symmetric matrix. Now what is meant by a skew symmetric matrix? Similarly, for a square matrix A to be said as a skew symmetric matrix, A transpose is equal to minus A. A transpose is equal to minus A. That is, the general element we are taking A transpose. Aji is equal to minus of Aij, or Aji plus Aij is equal to 0. But in some particular cases, when I is equal to j, in particular cases when I is equal to j, we can say that Aji plus Aii plus Aii is equal to 0, or 2Ai is equal to 0, which means that Aii is equal to 0. What do you mean by Aii is equal to 0? That means A11 is equal to 0, A22 is equal to 0, A33 is equal to 0. That means for a skew symmetric matrix, we can say that the diagonal elements are always equal to 0. Diagonal elements are always equal to 0. Consider an example. B is equal to 0 EF minus E 0 G minus F minus G 0. Now, let us consider the transpose. B transpose. What is B transpose is equal to? rows becomes the column. Row become the column. 0 E F. Second row minus E 0 G and minus F minus G 0. So when you compare these two, we can see that the elements are the same. The upper portion, only the signs are different, and the lower portion, the signs are different. So we can say that it is equal to minus of 0 E F E minus E 0 G minus F minus G 0. And that is nothing but minus B. So B transpose is equal to minus B. That means for a skew symmetric matrix, we can say that A transpose is equal to minus A, or we can say B transpose is equal to minus B, because here I have taken an example with the matrix B. This is, and the peculiarity is that the diagonal elements of a skew symmetric matrix are always equal to 0. Okay, once again recollect, a symmetric matrix means the transpose is equal to the same matrix. And for a skew symmetric matrix, what is the peculiarity? A transpose is equal to negative of the matrix. And one more thing, for a skew symmetric matrix, the diagonal elements are always equal to 0. Diagonal elements are always equal to 0. Now we have to consider some properties related to skew symmetric matrices. Properties related to skew symmetric matrices. Theorem. For any square matrix, with entries as real numbers, A plus A transpose is symmetric and A minus A transpose is skew symmetric. It's an important theorem. You get problems based on this. For any square matrix, so symmetric and skew symmetric matrix, the basis is it's a square matrix. For any square matrix with entries as real numbers. Entries as real numbers means the elements of the matrix are all real numbers. What is the first one? A plus A transpose is symmetric. Symmetric means when you take the transpose, you get the same matrix. And A minus A transpose is skew symmetric. What do you mean by skew symmetric? When you take the transpose, you get the negative of the matrix. Keep in mind. So, first property, we have to prove that A plus A transpose is symmetric. That means you are finding out the transpose. It is equal to A transpose plus A transpose the whole transpose. What is the reason? Because you have studied A plus B the whole transpose is equal to A transpose plus B transpose. These are the properties you have studied with transposes. This is equal to, who can give me the answer? Yes, give me the answer. This is equal to A transpose plus A transpose the whole transpose. It is equal to A, because you have studied one more property, A transpose the whole transpose is always equal to A, or this you can write it as A plus A transpose. So from where did you start? A plus A transpose, the whole transpose is equal to A plus A transpose, the same matrix you are getting. That means it is a symmetric matrix. It is a symmetric matrix. So, sum of A plus A transpose is symmetric. Sum A matrix plus transpose of the matrix is equal to symmetric matrix. Now, we have to prove that A minus A transpose is skew symmetric. Now, what do you mean by skew symmetric? When you take the transpose, you get the negative of the matrix. So, I am going to take the transpose. A minus A transpose, the whole transpose is equal to A transpose minus A transpose, the whole transpose. Why? Because of the property A minus B, the whole transpose. A minus B, the whole transpose is equal to A transpose minus B transpose. And that is equal to A transpose minus A transpose, the whole transpose is again equal to A, or you can write this as minus of A minus A transpose. So, what is the result you have got? A minus A transpose. This is your matrix. Matrix, when you take the transpose, you are getting the negative of the matrix. A minus A transpose. So, that means the difference becomes a skew symmetric matrix. So, A plus A for any square matrix, it should be a square matrix. For any square matrix with entries as real numbers, with the elements as real numbers, A plus A transpose is symmetric. Keep in mind, symmetric. A transpose is equal to A, and A minus A transpose is skew symmetric. This is a very important property. I hope you understood this and all of you are writing along with me. Okay? Yes. Now, one more theorem followed by the above theorem is you get many questions from this section. Any square matrix, any square matrix can be expressed one minute, sorry. Any square matrix can be expressed as the sum of a symmetric matrix, symmetric, and a skew symmetric matrix. So, what they have said, any square matrix can be expressed as the sum of a symmetric. Just now we have proved it can be A plus A transpose is symmetric, and sum A minus A transpose, symmetric matrix and a skew symmetric matrix, but you add a scalar along with it because it doesn't make any difference. When you expand this, you get A by 2 plus A transpose by 2 plus A by 2 minus A transpose by 2. A by 2 plus A by 2, which is equal to A. So this is the theorem that is telling, that is, a square matrix can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. But you are adding a scalar quantity half, 1 by 2, 1 by 2, and when you expand it, you are getting the same matrix. And by adding the scalar by multiplying with the scalar quantity, it doesn't make any change. Now, based on this, you have to do the problems. Now, sometimes this can be asked as a question. That this can come as a theoretical question also. Prove that any square matrix can be expressed as a sum of a symmetric and a skew symmetric matrix. So for the first part, you write the previous theorem and then come to the second section. So you get the full marks. Okay. Now let us come to certain examples. Express the following as the sum of a symmetric, I am writing in short form, symmetric and skew symmetric matrix. It should be the sum of a symmetric and a skew symmetric matrix. Let us take an example A. 1, 5, minus 1, 2. So when you get such a question, at once it should come to your mind, you have to find the transpose, isn't it? Because transpose is there. Okay. So what is the transpose of this matrix? Rows becomes the columns. 1, 5, minus 1, 2. Let us take P. Name it as P, and we are writing P is equal to half of A plus A transpose, because we know that half of A plus A transpose is symmetric. We will check it. Is equal to half of curly bracket A. What is A? 1, 5, minus 1, 2 plus 1, minus 1, 5, 2. Close the bracket. So when you do such an operation, first you have to add the matrices. Add the matrices because it is inside the curly brackets, which is equal to 1 by 2 into matrix. How do you add the matrix? Add the corresponding elements. 1 plus 1, 2. 5 plus minus 1, 4. Minus 1 plus 5, 4. 2 plus 2, 4. Now multiply with the scalar matrix, scalar number 1 by 2, which is equal to matrix 1, 2, 2, 2. So this is your P. Now what have you to prove? P should be symmetric. Let us take P transpose. P transpose is equal to row become the column 1, 2, 2, 2. And P transpose is equal to P. That means it is symmetric. Remember, in an order, P is symmetric. Half of A plus A transpose. Now, we know that half of A minus A transpose is skew symmetric. So, now we are coming to the point. Let us take Q. Q is equal to half of A minus A transpose equal to half of curly brackets. What is A? 1, 5, minus 1, 2 minus A transpose 1, minus 1, 5, 2. equal to half of, how do you subtract? Subtract the subtract the corresponding elements. 1 minus 1, 0. 5 minus minus 1, 6. Minus 1 minus 5, 4. 2 minus 2, 0. Which is equal to, when you multiply, 0, 3, 2, 0. Zero, 3, 2, 0. This is your Q. Isn't it?
Minus 1 minus 5.
Minus 1 minus 5, which is equal to minus 6. Yes, very good. I made a mistake. Yes, very good. Thank you. So that means the students are attending the class. Yes. Now, Q transpose is equal to 0, 3, minus 3, 0. And this can be written as minus of 0, 3, minus 3, 0. Which is equal to, what is this? This is your Q, minus Q. So, you are left with Q transpose is equal to minus Q, which means it is skew symmetric. Now, our problem is not over because we have to show that it is a sum. A is a sum of a symmetric and a skew symmetric matrix. So, we will add P plus Q because P is symmetric, Q is skew symmetric. What is P? What is P? 1, 2, 2, 2 plus what is Q? Q is equal to half of A minus A transpose, and that is equal to, what is Q is equal to? 0, 3, minus 3, 0. Equal to corresponding element 1 plus 0, 1. 2 plus 3, 5. 2 plus minus 3, minus 1. 2 plus 0 is equal to 2. And that is your A. So, we have expressed A as a sum of a symmetric and a skew symmetric matrix. Symmetric and a skew symmetric matrix. So, we are taking P as half of A plus A transpose. Prove that P transpose is equal to P plus, it is always symmetric. Then you take Q is equal to half of A minus A transpose. This is always a skew symmetric matrix. And finally, the students always forget to write the last step because we have to show that P plus Q, symmetric plus skew symmetric, it is always equal to the same matrix. I hope this is clear to you. Now, when you go to the exercise and assignments, do it, and if you have any doubt regarding this, you can call me and clarify your doubts. Now, we have to do one more question because this question comes as a multiple choice question. Most often I have seen in the question paper. So, let us take that example also. A is equal to, here the elements are trigonometric functions. A is equal to cos alpha minus sin alpha, cos alpha. Then, and A plus A transpose is equal to I. Find the value of alpha. This is a one word question. So, A plus A transpose is equal to I. You know what is A? You can find A transpose. What is I? Yes, it is a identity matrix. The diagonal elements are all equal to 1. Okay, very good. So, this is A cos alpha minus sin alpha cos alpha plus the transpose cos alpha minus sin alpha cos alpha is equal to, what is it equal to? It is equal to I. I means the identity matrix. Identity matrix means here we should take it is in the order 2. 1, 0, 0, 1. Okay. Add the corresponding elements. Cos alpha plus cos alpha, 2 cos alpha. Minus sin alpha plus sin alpha, 0. Sin alpha plus minus sin alpha, 0. Cos alpha plus cos alpha, 2 cos alpha is equal to 1, 0, 0, 1. Okay. So, LHS is equal to RHS. That means orders are the same, corresponding elements are the same. That is 2 cos alpha is equal to 1. Cos alpha is equal to 1 by 2. So, for what angle cos alpha is equal to 1 by 2? It is equal to 60 degrees, or in radians it is equal to pi by 3. This question is frequently asked. So, alpha, cos alpha is equal to 1 by 2, or that is alpha is equal to 60 degrees, or that is equal to pi by 3. Very good. Here we can say one more thing. Alpha is equal to cos inverse of 1 by 2, and cos inverse of 1 by 2 is equal to 60 degrees, or that is equal to pi by 3, because you have already studied inverse trigonometric functions. Yes, very good. Now we will do a 3 by 3 matrix, and with that we will conclude this section. Are you ready? Yes. Okay. So do along with me. Express the following as the sum of a symmetric and a skew symmetric matrix. It's a 3 by 3 matrix. Let us take A is equal to matrix 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Now, what is your A? You should express this as a sum of a symmetric and a skew symmetric matrix. What is the first step? Let P is equal to, do along with me. Don't look on the board. Look only in your notebook. P is equal to half of A plus A transpose equal to half of A. What is A? 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, plus transpose 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Equal to half of matrix 6 plus 6, 12, minus 2 plus minus 2, minus 4, 2 plus 2, 4. This will be minus 4, 3 plus 3, 6, minus 2, 2 plus 2, 4, minus 2, 3 plus 3 is 3, 6. And that is equal to, when you multiply each element by 1 by 2, It is 6, negative 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is your P. Take P transpose. 6, negative 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Compare these two. 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. So, we can say that P is equal to P transpose. That means your conclusion, it is symmetric. You have to write this as symmetric because it carries marks. Now, consider the next one. What is it? Q is equal to, let Q is equal to half of A minus A transpose equal to half of A minus A transpose, that is half of A. What is A? 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, minus transpose. So, row becomes a column. 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, which is equal to half of, subtract, 6 minus 6, 0. Be careful when you subtract. Minus 2 minus minus 2. That becomes, here becomes positive, is positive. So, this is equal to 0. Then 2 minus 2, 0. Minus 2 minus minus 2, 0. 3 minus 3, 0. Minus 1 minus minus 1, 0. 2 minus 2, 0. Minus 1 minus of minus 1, that is 0. 3 minus 3 is equal to 0. When you multiply, you get it is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. Q transpose is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. And that is equal to minus Q. Because 0 doesn't have a sign. Therefore, Q transpose is equal to minus Q. That means it is skew symmetric. Q transpose is equal to minus Q. It is skew symmetric. Now, we have to express it. P plus Q. What is P? 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, plus 0, 0, 0, 0, 0, 0, 0, 0, 0. And this is, of course, it is symmetric, and this is skew symmetric. 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. And this is nothing but your A matrix. So, A matrix is expressed as the sum of a symmetric and a skew symmetric matrix. sum of a symmetric and a skew symmetric matrix. I hope all of you have understood this concept. Okay. Now you can do all the questions based from your textbook. Thank you.